Welcome to our lesson on annotating one-step word problems. There's a note that I wrote up here at the top, and it's important that we read it. It says you can never isolate the variable when you're setting up an equation for a word problem. So, for example, I could never set up an equation that say like x equals 2 plus 6 or something like that because x is all by himself already. We need to set up an equation where something is happening to x. We're adding or subtracting or multiplying or dividing x. And then we would solve it. So you can never have an equation where x is by himself. If you do come across an equation where you set it up and x is by himself already, go back and try again because you know that the answer is not correct. Okay, there's a couple of directions here. There's a lot of directions. So each of these problems is going to take us a couple moments. The first thing we have to do is define a variable. What does that mean? That means we're going to say what x equals. Is it the number of dogs? Is it the number of seashells? Is it the number of cups of flour? Then we're going to annotate each problem. We've been doing that this year where we circle the important numbers and the important words. We'll set up an equation, solve it, and then of course we need to label because these are word problems. All right, so let's go ahead and get started. Our first question says Lindsay is baking a cake. The recipe calls for 6½ cups of flour. She already put in 2 cups. How many more cups does she need to add? Well, I'm going to, first of all, circle a couple of words or highlight a couple of words. You could circle or highlight a couple of words that are really important. The next thing I'm going to do is try to identify which one of these numbers is my total. I know that my total isn't going to be x because we can never isolate x, so it's not going to be something equals x. The recipe calls for 6½ cups of flour. She already put in 2. Because it says the recipe calls for 6½, I know it's going to be something, something, something equals 6½. That's my total right there. So I want you to annotate that equal sign. Okay, next sentence. She already put in 2 cups. How many more does she need to add? That tells me right there that I'm going to be adding. Okay, how many more? I'm not sure. X. So I have 2 cups, and I'm adding some other amount of cups, x cups, and it's going to equal 6½. So I've got 2 cups plus some more cups will equal 6½ cups of flour. Okay, so and I forgot to define my variable. X is the number of cups she needs to add. She needs to add. Okay. So now I can go ahead and solve. I defined my variable, I annotated the problem, set up the equation, so now I'm going to solve. In order to get x alone, the first thing I want to do is swap these 2 numbers around. And this is already a plus sign, so I can use my commutative property of addition to flip them around. So x plus 2 equals 6½. Now the reason it's important to do that is that way you can see what operation is going with the number 2. So right now we are doing x plus 2. So now I need to subtract 2 to cancel that out. And I'm going to be left with x equals 4½. 6½ minus 2 would be 4½. And then I need to label cups. You could say cups of flour, whatever you want. But we need at least a little bit of a label. And that's it for our first problem. Okay. On to number 2. You and 3 friends go out to dinner. Okay, I'm going to underline that. Sounds important. The bill was split evenly. Splitting evenly. That sounds like it might be an operation. And each person paid a total of $37.28. How much was the total bill? All right. Well, the first thing I need to recognize is that it's you and 3 friends. How many people is that? There's you. And then there's 3 friends. Friend 1, friend 2, friend 3. I don't know why friend 2 has such a big head, but we like it. Okay. That's 4 people right there. So I'm actually going to annotate, and so are you. Annotate a little 4 right there. We've got 4 people out to dinner. The bill was split evenly, and each person paid a total. So I know it's going to be something, something, something equals $37.28. How much was the total bill? So I need to define a variable first because I'm searching for the total bill. That's what I'm going to make x. X is the total bill. Now total bill means when the little receipt comes and it shows how much the entire table, all 4 of you eating, owes. So here's your bill, and there's a total at the bottom. That's what we're searching for. We know that each person paid $37.28. $37.28, $37.28, and so on. But we don't know how much the grand total was. Now, I bet there's a lot of you thinking, well, I know a different way to solve this where I wouldn't even have to have x. That's true. There are other ways to solve this problem, but what we are learning about right now is one-step equations. So I want you to make sure you're focusing on the fact that we're building equations. These are simple problems. These are really more 6th grade standards because they're one step. When it gets more complicated, you can't just figure it out any way you want. So we're practicing with this, even though there might be easier ways to do these problems. We're practicing one step so that 2-step feels easy once we get there. Okay, so back to the problem. 4 friends go out. The bill was split evenly. Split evenly tells me that we're doing some sort of division. So I've got my 4 friends. They're splitting the bill evenly. So I've got a bill. We don't know how much it is, X. I split it between my 4 friends, and each person pays $37.28. Okay? Now, some people are probably like, why didn't I put the 4 on top? You're not splitting the 4 people. You're splitting the money that the bill cost. So we're taking the bill, splitting it between the 4 of you. Okay, so the next step is to get x alone. Right now, x is being multiplied. So very carefully, right next to my equation, I'm going to multiply, x is being divided, so to reverse that, we're going to multiply. Multiply by 4 on that side, multiply by 4 on this side. If you were to make that into a fraction, the 4's cross-reduce. So it's going to say x equals $149.12. $149.12. So that is my total bill. If I were to split that between 4 people, we would each have to pay $37.28. So I know I'm right. My dollar sign there was my label. So I'm all done. Okay, number 3. Ellie babysat for 3.5 hours. She made a total of $29.75. How much money does she make per hour? Okay, step 1, we need to annotate this. We see 3.5 hours, which is important, and we see her total. Now we need to annotate the important words. 3.5 hours, she made a total. So I know it's going to be something, something, something equals $29.75. How much money does she make per hour? Now remember, per could be multiply or it could be divide. It depends on the situation. But here, we're working for an hour and another hour and another hour and another half hour. And so we're continually working, and so that's going to be a multiplication. So I'm going to annotate, and so are you, multiply right there. So let's define our variable. We want to know how much money per hour, so that's going to be our x. X is dollars per hour that she makes. She is babysitting for 3.5 hours, and she makes something per hour. So that is multiply right there. 3.5 times x, 3.5x. She makes a total, which means equals. Makes a total of $29.75. Okay, now, I have my equation set up. I'm going to need to solve, so I will show that I'm dividing both sides by 3.5. 3.5 divided by 3.5 is 1, so it gets x equals. Now, I don't know this problem's answer in my head, and so I'm guessing you don't either. What you need to do is set up on the side, not below, because that would be confusing for the teacher grading it. On the side, set up a division problem. Remember, the first number goes in the division house. Second number goes outside of the division house. Now, and make sure you're writing this out with me as well. We can't divide with the decimal outside of the house, so we've got to bump the decimal over. So this is actually going to become 35 on the outside and 297.5 on the inside. And remember, we just want to raise the roof, bring the decimal straight through. And then 35 does not go into 29, but it does go into 297. And you can kind of know that it's definitely going to be a number lower than 10 because 35 times 10 is 350, but it's kind of close. So I would guess, let's say 8. So over here, I'll kind of just check it out because I'm guessing that it goes in 8 times. 5 times 8 is 40. 8 times 3 is 24 plus 4 is 28. So I'm going to subtract 280. Oops, sorry, and put my 8 in there, of course. And I'm left with, oops, sorry, not 97. I'm left with 17. And then I drop down my 5. So let me erase that. That looks really messy. I'm left with 175. And 35 actually goes into 175 5 times perfectly. And then I'm done with the problem. So 29.75 divided by 3.5 is 8.5. But that's not really a good answer because we're talking about how much money. So my answer here is going to be $8.50. Oh, sorry about that. $8.50. And if you want to be even more descriptive, you could say per hour. So she's making $8.50 every hour. And if she works for 3.5 hours, she'll make $29.75. Okay, the last one that we're going to try together, and then the other 2 you're going to do by yourself. Brandon ran 15 miles this week. This is 7 miles less than the number of miles he ran last week. How many miles did he run last week? Okay, so I can annotate first. He ran 15 miles. This is 7 miles less than what he ran last week. So we know less than is a minus. So go ahead and annotate that minus. I would put it above if you could, but I don't have any room up there. How many miles did he run last week? Well, it didn't give us a whole lot of information, but let's start with what our x is. Miles ran last week. This is how many miles did he run last week? Okay, so x is our miles ran last week. It says that Brandon ran 15 miles this week. That means that 15 is our total. We don't see the word total in there, but we can infer that it is a grand total of 15 because that's how much he ran this week. So it's going to be something, something, something equals 15. This is 7 miles less than last week. Well, we know last week's was x, and then we need 7 less than that. But less than is that weird minus where it kind of flips it around. So right now we know it's 7 less than last week, which is x. But when I see less than, it flips these 2 around. So we're starting with last week's and we're taking off 7. So I've got my equation, I've got my definition of the variable, and now I can go ahead and solve. So I'm going to add 7 to both sides, and I get x equals 22. And then I need to label it. So 22 miles last week. Now, a couple of you were probably thinking, oh, I could have, and I don't want you to write this out, but I want you to watch. I could have just said x equals 15 plus 7. That would be marked incorrect. Part of the standard is setting up an equation that goes with the word problem. So because it says 7 miles less than, we needed to show x minus 7. The other reason that this would be wrong is because x is isolated. You can't have x by himself. If you want to use that to check your work, though, of course you could do that. Okay, I'm going to talk through number 5 and number 6 so that when you go to do it by yourself tonight, you kind of have a good understanding of it. Sydney's making bracelets. She has 1 long piece of string. She cuts the string into pieces that are 2 2/5 feet long. She makes a total of 5 bracelets. How long was the original piece of string? So here's my hint here. We're starting with like a really long piece of string, and we're splitting it, we're cutting it into pieces that are 2 2/5. Okay, so you know you're starting with x, you're splitting, which is division, cutting by 2 2/5, and then it's going to equal 5 bracelets. When you set that problem up, it's going to have a mixed number in the denominator, so your first step is going to need to be making it improper. Okay, next. Drew hasn't looked at her bank account in a while, so she's not sure how much money is in there. She spends $45.30 at the mall. When she gets home, she looks at her online bank statement and notices she has withdrawn her account and has a total of negative $14.25. How much did she start with? She's going to start with less than $45. That's my hint there. All right, thanks for watching. Have a good day.